3, 2, 1. Boosters in ignition. And liftoff of Artemis 1.
When you see a rocket blast off into the skies, it's often normal to get lost in amazement and forget how incredibly difficult the required years of planning, preparation, and execution are. Still, launching a spacecraft into orbit is just the beginning, because once it's up there, you need to keep it alive and ensure it gets back home safely. Space missions are no walk in the park. Launching a rocket requires an intricate interplay of engineering and physics that boggles the mind. You need to generate enough thrust to overcome Earth's gravity and atmospheric drag, while also ensuring that the spacecraft and crew are protected from the extreme temperatures and pressures of launch. It's like lighting a giant firecracker and hoping it doesn't blow up in your face. Still, that doesn't fully capture its complexities. And once you're in space, things don't get any easier. If only it were that simple. You're dealing with various hazards like micrometeoroids, radiation, and temperature extremes. Plus, you're constantly moving at incredibly high speeds, so even a tiny mistake or miscalculation can have catastrophic consequences. Nevertheless, the return trip is arguably the most difficult part of any space mission. Returning to Earth requires a delicate dance of physics and engineering. You need to slow down from orbital speeds without burning up in the atmosphere or slamming into the ground. It's like trying to land a paper airplane from the top of a skyscraper, except your life is on the line. Amidst all these difficulties, space missions are exceptionally rewarding. The technology and knowledge we gain from exploring space can help us solve some of humanity's biggest problems. What about the sense of awe and wonder that comes from seeing the universe up close? Indescribable. Navigating space is a challenge like no other. Every object in space is constantly moving and traveling at very high speeds. This constant motion makes it difficult to predict where things will be in the future, making navigating through space similar to navigating through a minefield. It takes incredible skill and precision to safely navigate a spacecraft through the vast and dangerous expanse of space, and the stakes are always high. So, when NASA launched its space probe Lucy on October 18, 2021, it had to surmount all of these challenges to make its way toward the Jupiter Trojans. NASA's Lucy is a space mission that will delight and excite scientists and stargazers. The $981 million space probe is named after the famous fossilized human ancestor Lucy, and its primary objective is to study the Trojan asteroids. Trojan asteroids, also known as Jupiter Trojan, are a large group of asteroids that inhabit Jupiter's orbit around the Sun. These asteroids have long captured the imagination of astronomers and the general public alike, but for very different reasons. For scientists, the Trojans present a rare opportunity to unlock secrets about the formation and evolution of our solar system. For the general public, the Trojans are a mysterious and alluring collection of space rocks that share Jupiter's orbit around the Sun, located about 5.2 astronomical units, AU, from Earth. The Lucy spacecraft is on a 12-year mission to study these Trojan asteroids. The spacecraft will fly by 7 different asteroids, including Trojans and Main Belt. The first flyby will be of the Main Belt asteroid 52246 Donald Johanson in April 2025. After that, Lucy will continue its journey, making its way to the Trojan asteroids, where it will fly by 6 different objects. These objects are named after characters from Homer's epic poem The Iliad and include Achilles, Hector, and Patroclus. These asteroids are believed to be remnants of the materials that formed our planet billions of years ago. In fact, The mission derives its name from Lucy, the fossilized human ancestor whose skeletons provided us with remarkable insight into the evolution of humans. Scientists hope that studying these asteroids will provide us with information to understand how our planet came to be and how our solar system was formed, just as studying the fossilized hominid provided crucial information about our origins. The hominid was named after the Beatles song Lucy in the Sky with Diamonds. Interestingly, the space probe carries a chunk of diamonds made in a lab. NASA has a great sense of humor, don't they? But what will the Lucy spacecraft actually do once it reaches the Trojan asteroids? Well, for starters, it will take a whole bunch of pictures. One of the mission's major objectives is to create high-resolution images of the asteroids, allowing scientists to study their surfaces and compositions in detail. To make this work, high-quality instruments like a high-resolution visible imager, LaLaurie, were imbued in the space probe. But that's not all. The Lucy spacecraft will also use a suite of scientific instruments like a thermal infrared spectrometer, LaTeS, and optical and near-infrared imaging spectrometer, LaRalph, to study the asteroid's composition, density, and other physical properties. This information will help scientists better understand the origins of the asteroids and shed light on the early history of our solar system. This is incredibly exciting, but it's also important to remember that the Lucy mission represents a major technological achievement. The spacecraft is equipped with state-of-the-art instruments and technology that will allow it to travel vast distances through space, gather data, and transmit that data back to Earth. It's a testament to the ingenuity and perseverance of the men and women who designed and built the spacecraft. But recently, the mission hit a snag when one of its solar panels failed to unfurl properly and latch after its launch in October 2021. The team tried a series of activities to fix the issue in 2022, which succeeded in further deploying the panels. However, they remain unlatched. After careful analysis and testing, the team decided to suspend further deployment attempts as the solar panels were over 98% deployed and strong enough to withstand the stresses of the mission. The solar panels produced the intended power level and were expected to have enough capability to perform the baseline mission. But what's interesting is that the team's confidence in the stability of the solar panels was affirmed by its behavior during a close flyby of Earth on October 16, 2022. The spacecraft flew within 243 miles or 391 kilometers of the Earth through the Earth's upper atmosphere, and the solar array held up perfectly. However, the team faced a setback in December 2022 when their attempt to deploy the solar panels produced only a small movement. Ground-based testing showed that deployment attempts were most productive while the spacecraft was warmer and closer to the Sun. As the spacecraft is moving away from the Sun, the team does not expect further deployment attempts to be beneficial. But the mission is not over yet. Thanks to the energy boost the spacecraft received during its Earth gravity assist in October 2021, it is now in an orbit that will take over 315 million miles, or about 506 million kilometers from the Sun, before returning to Earth for a second gravity assist in December 2024. Have you ever wondered how NASA's spacecraft are able to travel such long distances through space and explore distant planets? Well, one of their key techniques is called a gravity assist. Picture this. A spacecraft is on a mission to explore the outer reaches of our solar system. But to get there, it needs to gain speed and change its direction of travel. This is where a planet's gravity comes into play. By carefully planning the spacecraft's trajectory, scientists can use the planet's gravity to boost its speed and alter its course. It's kind of like a slingshot effect, where the spacecraft uses the planet's gravity to sling it around and shoot it off in a new direction. NASA has used this technique in many missions, including the Voyager missions to the outer planets, and that's what it's using for the Lucy mission. Gravity assist is a great way to accelerate spacecrafts, but requires careful planning and precise calculations. However, it's not just about speed and direction. Gravity assist can also help conserve precious resources like fuel. By using a planet's gravity to change course, the spacecraft can use less fuel and travel further than it would be able to with conventional rocket propulsion or, in Lucy's case, solar energy. So, while scientists were working on unfurling the solar panels, the gravity assist helped to propel the probe, conserving its fuel. Over the next year and a half, the team will continue to collect data on how the solar panels behave during flight. This is important because in February 2024, the spacecraft will operate its main engine for the first time. The team needs to ensure that the solar panels can handle the increased power demand during this maneuver. As the spacecraft warms up during its approach to Earth in the fall of 2024, the team will reevaluate if additional steps to reduce risk will be needed. The Lucy mission team is determined to make the most out of this journey to explore the Trojan asteroids, and they won't let a minor setback hold them back. After watching The Message from Lucy, NASA Did Not Want You to See, it's not hard to feel a sense of curiosity and wonder. What else is out there that we're not supposed to know? But fear not, we have another intriguing video that's sure to tickle your interstellar fancy. If you've ever found yourself wondering whether we could bring Voyager 1 home, then Bringing Voyager 1 Home, Is It Possible? Is the video for you. Not only does it explore the possibility of bringing this beloved spacecraft back to Earth, but it also dives deep into the technological challenges and ethical considerations that come with such an endeavor. It's a thought-provoking and fascinating watch that's sure to leave you feeling both enlightened and inspired.